Hello, everyone. Thank you for joining Blockchain UBC January Research Talk. And today we have Denis from Zenroom talking about the basic capabilities and advantages of Zenroom. So Zenroom is a tiny, secure, open source.
Zenroom.
Oh, Zenroom. Yeah. Sorry. Yeah. Sorry. It's Zenroom. Not Zenroom. We use Zoom too much, so I'm sorry. Today we are talking about Zenroom, not Zenzoom. And Zenroom is a very secure open source virtual machine that runs on any platform, even on a chip or web page. It performs cryptography, including signatures, hash, ZTP, homomorphic, and so on multiple curves, blockchain interoperability, and general computation. Programmable in a non-code English-like language. In this webinar, we will offer a hands-on demonstration on how to use and expand the virtual machine. Yeah, so without further ado, I will just hand it over to Denis.
Thanks, Changlu, and please welcome also my colleague Andrea Dintino, who kindly joined. He is, I believe, the best one to demonstrate and use, and has been the best one documenting our software. So often I try to explain it to people, but he is better than me at connecting really to a larger audience. So I'm grateful he's here. I will make an introduction to our organization, which is an unusual construction between public sector and private sector. We come from Europe, and we work mostly for the European Commission. So I will show you in the first part of this presentation the projects, because we are a purpose-driven organization. And purpose for us means we like to know why we do things, and we like to know that it benefits society. So I will show you first like what we work on, why we do it, and then a bit of an academic background on how we design our software. And then finally, I will show you how to use it. So you will have a hands-on section in this workshop. It will last about 1 hour with question and answer. Correct me if I'm wrong, Changlu. Did I note it well?
Yeah, it's correct.
Good. And our objective, our goal for this presentation is that you come back with one more tool in your belt to use in your professional and academic life for prototyping and also developing cryptographic protocols, but also to interest you into an internship with us, because we are very open to internships with high-profile institutions in both technical and theoretical mathematical fields. And we have a successful stage program with one university already in Trento, and we are open up to the other side of the pond for you in Canada to join us if you're interested. So, yeah, as I mentioned briefly, we are a non-profit organization. We exist since more than 20 years now. And our expertise is in developing tools that act on the texture of communities and society. So we have been working in the smart city sector, in the energy grid, innovation, and of course, we couldn't miss the crypto sensation in the world. So we have a span, as I said, since 20 years. We are as old as Google, one could say, but not as big. We kept small, and we worked mostly as a think and do tank in the context of European research and development. So these are our main topics, and this is more of a bird's eye of what the think do tank covers as a analysis that we love to define techno-political, in the sense that our technological development has a social and political impact on society that we like to acknowledge in a conscious way. So These are the main campaigns we are part of, and they can explain some of the design choices that we have made along the way. One of them is the public money for public code. Believe it or not, in Europe, it's not obvious that public-funded research is published as open source. We like to publish as open source, and we like all public sector to publish open source code for what is funded publicly. So we are actively campaigning to renew the research funding in Europe and also the innovation actions to produce open technology for both private and public sector. We are also strong advocates of reusing technology. We like to acknowledge always the footprint of technologies we develop. Software runs on hardware and shapes the demand for more or less resources in hardware. So we want to know and we want to minimize the demand for resources on the hardware that we deploy. So what we do is we use refurbished infrastructure. We reuse computers also in our own infrastructure, but also we like to optimize our software to be back portable on existing infrastructure, on legacy infrastructure, instead of requiring always a new infrastructure, which happens often. Just an example, Windows 11 requires 8th generation CPUs for trusted computing, and this has a carbon footprint that I think Microsoft cannot even offset with its whole budget, because everyone buying a new computer means new computers being produced. And yeah, we are concerned about this. So in our small niche, we like to think of how to reuse existing infrastructure rather than asking companies, organizations, public sector institutions to buy new hardware. What we do in terms of code, you can just dive in. We have a GitHub organization that hosts most of the things we developed. You can see we are beyond 150 repositories. Some of them are more popular, some of them less. They are all for you to just like grab and study and modify and redistribute. We use the GNU GPL license as the main line license, and we are also associated with the Free Software Foundation Europe and endorsed by the Free Software Foundation US. These are some of the standards, organizations, and consortia we work with, from the most famous ISO to the least known local organizations like the Rome Call in the Vatican, busy with algorithmics, passing by private companies and huge groups like InfoCert for authentication and signature technologies, and many other consortia that you see here. We have been participating with our organization to the eddsa European Blockchain Initiative as second and third course winners of the commercial procurement, pre-commercial procurement that was run, and we work regularly for the European Commission. Zooming in, one of the projects that give birth to the technology that I'm going to show you is Decode, a flagship project for the European Commission that we led as technical coordinators up to developing the technology that you see. So Zenroom and the Zencode language were designed in the framework of this project, which posed very hard questions already in 2016, asking how we put citizens in control of their data. We noticed that in cities, namely high-density settlements, desires and needs travel at very fast speed, and companies like Uber or Airbnb or even Tinder exploited this richness in demand by connecting people very fast to what they needed through algorithms that are completely proprietary and through data silos that collected people's private data to actually serve them a targeted service. So we argue that this data is public data, It is a public good as private data anonymized, and it should be put in the use of anyone in a city wanting to develop new services. So we work through a web of legal and technical issues. We were advocating the GDPR directive, the General Data Protection Directive in Europe at its inception. And we think that the tools we produced help the future organizations to build a real plugged-in public good using data framework that is privacy respecting. So this is a glance in a team from one of our projects. This was in Hamburg with Helmut Schmidt University and with the Fab City, the local Fab City in Hamburg. It's expanding through other Fab cities, just to show you some faces. And this is Zenroom and all the links where you can find more information about the technology that I'm going to show you. So the first link is the website where you see a showcase of features. The second is the code repository, which you see is very active. The third is a playground that I'm going to show you also with the help of Andrea later on. And fourth is the documentation of our language, which you will see is very rich and has been compiled through now 6 years of development. What is Zenroom based on? And this technology that I'm going to show you is mostly elliptic curve cryptography, because it's a recent and less explored, at least at the time we started, type of cryptography that allows many advanced schemes like zero knowledge proof and plugging in also with homomorphic encryption. We will see like many things that can be done with it. So the first thing that we implemented really in Zenroom were elliptic curve primitives that allow us simple things like asymmetric cryptography, like asymmetric key cryptography, namely signing and also like session keys that are handshaken between parties without sharing any secret, but just a public key. So think of GPG. GPG also uses elliptic curve cryptography, started with RSA. RSA is an older way to implement what we do with elliptic curve. We extended our technology to work also with quantum proof by now. So we also support quantum proof algorithms, and we try to normalize everything to a language that is easy to use. So yeah, elliptic curve can become quickly very, cryptography in general, very complex. And these that you will see on the left, also in other slides, are snapshots of mathematical papers. Sometimes hard to read also for computer science students. They mostly elaborate on mathematical models that allow us to do what we do with cryptography. What is our mission is to implement the most advanced functionalities that are now nowadays in cryptography. One of them is showcased here, is a Miller loop, so meaning working with twisted pairs, so second order curves. And we do that in a way that keeps very close to the language of papers, of mathematical formulas as prototyped on computers, and finally to human language. We try to draw a line that goes from the mathematical paper to the integration engineers to the final users. How do we do this? Well, here you see a simple implementation of a hypothetical signature scheme. And on the left side, you see the explanation in a mathematical paper. The signature schemes exploits the Miller loop, so the function of some elliptic curves to have twisted pairs. and elaborates a signature scheme, which ultimately is a simple multiplication, as you see, of a number by a generator. The G2 is a curve generator. The SK is a secret key that we just generate with a random. And the public key is a multiplication between the secret key and the curve generator. So this is a scheme that you will find in many cryptographic schemes, from Schnorr signatures to ecdsa. Here in M, we put a message, so a byte octet array, and we do a hash to point. So we hash the message to a point on the curve, and then we multiply this point by the secret key. This is the way we generate a signature. And then to verify the signature, we assert a relation between the public key and the signature, and the generator and the signature. I mean, sorry, the public key and the hash of the message, and the generator and the signature. So it's the assert that you see there. From the mathematical paper to this pseudocode, which is actually a dialect of Lua, is pretty simple. So I believe I'm not really doing a good job. It's just easy to read this and comment on. And I believe even if you don't understand the mechanisms, the mathematics behind it, you can understand and read what I'm saying. So the code on the right, as you see, I'm keeping the same. And now I'm substituting the code on the right with the code on the left, which is Zencode. The code on the left is a sequence of statements that flow from up to down and need to be true as they go on. So you can see these, if you have a background in computational linguistics, as a programming language like Prolog, so logic programming. It's a very simple one. Every statement you do must be true. And these blocks, they are separated in three parts: the given one, the when, and the then. If you see an and at the beginning of a phrase, then it's just referring to the first when. It's continuing the current section. So we have three states that actually configure the heap of the virtual machine in a different way for security reasons. The first phase, given, is data acquisition. So it operates data recognition or declares data structures. Like, I am known as Alice means that when I will refer to me or mine, it will be a table whose name is Alice. I have my keyring means that it will verify that a valid keyring has been loaded from the input. The input is always a JSON data flow, a channel, let's call it. There are two input channels. One is keys and one is data. They are separate so that the application developer doesn't need to mix delicate data, and that keys can be retrieved from a secure enclave. So the data recognition phase makes sure that all the data that we mean to compute is acquired. If it is not, then the programming will stop. For instance, if a keyring is not found, or a valid BLS signature, or a string named message, as I'm declaring, is not found in the input, the program will stop running and will report the error message in a meaningful way. So pointing out that this thing that we were supposed to receive as input is missing. Then we go to the when phase, which is the read-write phase, in which the computation really happens. So in the when phase, we can create new keys, we can create public keys out of them, and we can create signatures, as you see in the code on the left. And in the last phase, the then phase, we print out things with the encoding, implicitly the encoding that we brought them in from. The default encoding is base 64, We support many different encodings, from hexadecimal to base 58 to all the most exotic encodings that crypto fandom has brought to us. So the then phase will print them out with the same encoding. This is the logical structure of Zencode. And believe it or not, the code on the left is executed. It is executed. I like to spend a few words on this slide before passing to the next, perhaps. This code is executed in less than 2 megabytes of RAM. So it's executed by the Zenroom virtual machine, which was payload is less than 2 megabytes also. So you have a binary that is smaller than 2 megabytes. It can be a library. It can be a static library in your program. It can be injected via WASM in a browser, and it will execute in less than 2 megabytes of RAM this code. This is designed to have an impact on our way to work. We work in transdisciplinary teams, and often we have integration engineers that need to take complex cryptographic code that has been tested in another environment by another team and insert it into a mobile app with a framework that is new. So what we do is we insert the VM, which is always the same and is a signed payload, into a WASM or a Android or a iOS library, or just a Windows DLL or a Linux static library. And that VM is able to execute code that can be uploaded just like a firmware. So later on, the cryptographers and the UX designers and also the domain experts who are not coders, but are people that know the business logic we need to execute, they will provide the Zencode. Actually, we have 3 pipelines. We work with integration engineers doing the app, with domain experts doing the Zencode, and with cryptographers doing the math behind every statement. So you can see these as CSS and PHP and HTML. You have people writing the copy, people writing the design, and people writing the logic, the hot swap logic behind a server to provide pages. We try to make as less stoppers as possible in the workflow, so people can work in parallel. We develop also crypto ourselves. We are that experienced and bold about it. One of the papers you see is mentioned in the footer, Reflow Crypto, which is a zero-knowledge proof powered signature scheme that supports multi-signature. And this is an example of how we translated our paper from the mathematical description to the code that runs behind a statement. This is a very complex paper. I think I have never written so much Greek into one single paper as in this math paper. And I come from also like studies of linguistics and ancient literature. I tell you, this is quite hard to put into code, something like this. And there are many pitfalls, I can say by experience. This is an example of how a zero-knowledge proof is computed. It may be familiar if you know zero-knowledge proofs. It gets pretty complex into code. And this is our credential verify PS on the right. That is the Lua dialect we modified, customized, and adopt inside Zenroom to compute the challenge, the zero-knowledge proof challenge. Somehow, as you see, it is possible to keep the same name of the variables in the paper and to make it readable in a simple way. What we want to do with this operation, imagine the credential verify PS on the right will be a statement of Zencode, one line of Zencode that will say, when I verify the zero-knowledge proof is correct. And what we want to do with our work is to make it possible for third-party reviewers to look at the code and say, okay, you're really doing what you're doing. Because we don't ask people to trust us. We believe code should be read and things should be judged from code. So with this, I invite you also in your future professional life to never trust code that is not readable, let alone code that you cannot read. So it's closed source. This was the introduction. I am gladly taking some questions by now. And please, Andrea, if I forgot anything, just integrate here. Else we go to the more hands-on phase.
Thank you very much, Denis. It's a wonderful presentation. I was not able to understand much of it because I don't have a technical background. I'm from business. But I see that we have a few people here that have a technical background. Maybe they have some questions. Yeah, so if you have any questions, please feel free to ask Denis.
By the way, we have business people working with us and writing Zencode.
Oh, wow.
Andrea is one of the main coders of Zencode, and he has a business background.
Officially, I cannot code.
I'm sure you are much better than me.
This is because we believe that often the overhead of communication between domain experts. So as a business researcher, you may be a domain expert, for instance, in energy grid economics, which are very complex and also regional, depending from region to region. So they have many variables. We work with clients from the energy grid and renewables sector, and they are researching since more than 10 years, some people, the field. They have incredible knowledge about how the laws work and how the business agreements work with various actors in the field. And this is knowledge that is hard to communicate to programmers. So when we go and develop things, we put them in front of Zencode because they can develop directly the business logic. And this has a tremendous impact on our ability to achieve fast and with high quality what we do.
Yeah, that makes a lot of sense. Yeah, I'm glad to hear that you are already paying attention to kind of the pragmatic value of your codes, and to make sure that it actually connects with industry practice. Yeah. Any questions? If not, maybe we can just move on to the demonstration.
Andrea, would you like to lead this part on Happy Room? Or
sure.
You are better than me at that.
I doubt, but I can try. Okay, let me share my screen. Okay, you should be able to see my screen by now.
Yeah.
All right, so basically anyone here, they can go on apiroom.net and do pretty much the same things I'm going to show. What is apiroom.net? So Jaromil introduced Zenroom. You can read more about it here, zenroom.org. Very important, Zenroom is written in C and Lua, and we have CI for binaries on Linux, Windows, Mac, Android, iOS. But more and more often, we happen to use the WASM transcompilation, which is wrapped into JavaScript and packaged in Node. So you can go to npm. Hold on a second. Let me try a different browser. npm. You can check on this. npm.js.com package Zenroom. And if you do, I don't know how familiar you are with the JavaScript toolchain, but if you do npmi Zenroom, you will install an npm package that contains Zenroom transcompiled into WASM, which is isomorphic, meaning that it runs in the browser or in Node. So what did we do? We implemented an IDE, an online IDE. IDE stands for Integrated Development Environment, I believe.
Yeah. Yes.
That allows you to type code that can be fed to Zenroom in our domain specific language called Zencode and run it directly in the browser. How do we do that? We start from the examples. So I'm going to start with something. Let me guide you shortly through the examples. So on top, we have, I think we have like 150, 200 that you can use them as a cookbook. On top, we have some miscellaneous scripts. Then we have generic cryptography. This part we skip from now. Those are scripts that show the Ethereum integration capabilities. If anybody is interested, I can give you a very tiny demo about that later. Bitcoin integration, then we can do quantum proof cryptography based on that implementing some of the algorithms that won the NIST competition that came out in 2022. This is something very, very hot in Europe right now. It's the cryptography required by the eidsa specification. Also, yeah, I don't think I need to talk about that, but just to mention it. Then we have two zero-knowledge proof flows. This one called Coconut that is not very well known, although it's probably one of the best algorithms out there. And we have BBS, which is getting quite some traction. Okay, I'm going to skip the rest. And I will jump into a script to do a signature. So I'm going to click on this. Sign object using asymmetric cryptography, eddsa. So this is an algorithm developed by DJ Bernstein, I think in 2013 or something, and has been gaining more and more popularity in the past few years because of its possibilities and characteristics. So I'm just going to click on this. This populates with code. Can you comfortably read my screen, or should I zoom in?
No, I can read.
I'll zoom in a little bit anyway. All right. So what you actually read here is code. So what Jaromil was showing you before, given when then, you can read that here. And here I can explain you what happens for each line of code. So those two tell Zenroom to load a keyring that can contain multiple private keys inside a JSON object called Alice. And here I'm loading one more object from here. So on top, we have the code, and in the bottom, in keys and data, we have two input channels. So here we load the input that we want to load, then different color and different keyword. Here we actually do the cryptography. When I create the eddsa signature of this object, here I'm renaming the output just for fun. Here we are in the third phase, which is used to print out the output of the computation happened in the previous phase. So if I press the run button, I'm gonna get the output of the script, which is in this case the string array I loaded in the beginning and the signature, which is this. Okay, so this thing is the script is actually computed in the browser, meaning that if I would disconnect from the web, the editor is gonna keep working anyway. How do you work with Zencode? We worked quite hard to build in this editor an autocomplete feature that helps people that don't know the DSL yet to get started. Let's say that I want to not only to sign, not only to assign this array, but I also want to hash it. How do I do that? I start typing hash, and the autocomplete pops up, suggesting me several statements I could be using. In this case, let's say I want to do an hash using SHA to 512. Okay, so what do I have to do? I have to replace the name of the object that is going to be hashed with the actual name of the object you want to hash. So I'm going to do this. I'm going to do copy. Here I'm going to do paste. Now we'll press run, and you will see that the output didn't change. Why didn't it change? Because I also have to print out the hash that I'm creating. So whenever I find a statement that starts with create, I know that the output of the statement is going to be an object named with whatever comes after the, meaning that the output of the statement is a JSON object called hash. So what do? I copy this, I paste it, and I type hash, and here we go. We have a brand new hash here. So this was a quick and rough demonstration on how to get started with Zenroom and Zencode. There are a bunch of other features I could show you in the platform, but I don't think we'll have time because it's a 9:45 for us. If anybody is interested in anything particular, I can try to talk about any of the stuff that you've seen here. Otherwise, perhaps I can show a couple of other things.
Yeah, perhaps it's interesting, Andrea, to show the final pipeline, like for the computer scientists and network engineers out there, how you can do a microservice out of this code in a few clicks.
All right. Let me pick up something. Okay. I'm gonna start some from scratch. Well, not from scratch. I'm gonna start. Yeah. All right. Okay. I will quickly create a script and an API that takes a string as input and returns a hash. Okay. My string array, let me call it, my string. Hello, UBC. This stuff we don't need anymore. Okay. So here, I'm going to tell Zenroom that instead of a string array, I have a string named my string. Then I'm going to tell it that the string the string is what I want to hash, and then I'm going to print the string and the hash. Okay, here we go. So what I can do now is I can click on the deploy button. Let me call this hash API. I'm going to click on the deploy button. That, as you can see, it has the floppy 3.5 icon. It is asking me to save a new contract. That's another name we use to define scripts. We call them smart contracts because they can run on chain and they run into a virtual machine. Anyway, I click on save. And after I've done that, I click on Open APIs, which you can only do if you are registered. And to register, you need to know the secret password that only now I know. So I click here, and I land on Test APIs. So I click this button, and I'm going to paste here what you see on the screen, because you can also access that. So basically, what I did was storing a Zenroom script as a file and let it feed another component in the Zenroom stack that we conveniently called rest room, because because the component has Zenroom inside and it exposed to the REST API. Therefore, we thought it made sense to call it restroom. And
we also have a good dose of sense of humor in naming it.
Correct. And I scroll all the scripts that I saved before. Disclaimer, I was bored a couple of weeks ago, so I started implementing a chat, which I more or less did using our stack. Anyway, so now here we find the script I just saved as an API. If I press on try out, I can execute it and it's going to return the output. And here it also gives me a curl to try out, which I am going to do. I think I need to do this. Well, I'm going to try it in front of you, but you can also try it yourself at home. Hello, UBC. Hello, hello. So if you run this curl from your machine, you should see you should see that something is returned from the from the curl string. I can also do something else even easier. I can just create an API that doesn't require an input that you can use directly in the browser. So for example, generate a random object. This one doesn't actually return that doesn't require any input because it just generates a random. Instead of a random object, I'm going to create a randomize. I have to create a random array. Never mind. I'll just create a random object.
Just an example. Yeah, there are various ways.
Randomize, create, pick up the random object.
It was up there. Maybe quickly show also the Docker export.
Yeah, but let me do this very quickly. So here it just generates a random number. I click and deploy. I refresh this here. My Ubuntu, yeah, just started. Okay, let me go back to this. So this is the one that I have created 2 minutes ago. Just to show you that this is not fake. Paste anyway, yes please. Here we go. It returns the hash and the original string. Let me change the string. Let me do a hello world. Here we go. The one that I created a minute ago is called random something. Here we go. And I can use it as a get directly in the browser. So I just copy this. And here we are. So the two scripts that I've just created, let's say that I wanna deploy a microservice running those two APIs. So what do I do? I do check 1 and 2. I click on export, and I have several options. So the last one exports only the scripts that I wrote. This exports a shell script that installs everything you need to get to this point. So to install Swagger and run the APIs. The first one exports a Docker file that allows you to do the same thing as before, but in Docker. So I can show you downloads, Docker file, We have it. Okay, let me call it Docker file BBC. And I can do this and open. Yes. So I have just the API room has just created this on the fly, which has created. So it has generated this Docker file which contains hash api.zen, and I think that I picked the wrong script. Yeah, I probably picked this one. I didn't pick 1 and 2. I was supposed to pick 1 and 2, but I picked the wrong. I picked this one.
The point
anyway.
is that the Docker file downloaded is ready to deploy into your Kubernetes cluster. It's a microservice which provides the cryptographic functions, simple as shown, or very complex as a signature or a multi-signature saving state in a database, and so on and so forth.
So this was an extremely quick and rough demonstration of our core component, on top of which initially we started building only components, but in the past 2 years, we have been building solutions. If you want to have a sneak peek, you can have a look at the homepage of our commercial spin-off, which is called ForkBomb, which shares the same physical address as Dynork and the same people working there. I'm going to paste you in here. It's taking a while because I think that I'm logged in. Okay, yes. Indeed, I am logged in WordPress. So if you look at products, oh my God. As soon as it's done loading.
And after these, which is, as Andrea mentioned, is our commercial spin-off, we have a non-profit that has scored quite some success. So we started having private clients asking us and to work for them. It doesn't take much effort, as you see with this stack. So we started a private company. Andrea is the very active and hands-on CEO of the company. And we serve also private clients now using our open source.
Those are solutions. Some are deployed and in production. Some are deployed and in beta. Some are still work in progress. And this is the list of components that we implemented on top of Zenroom. So that's the core component, and this is some of the stuff that runs on top of Zenroom. For some reason, it doesn't want to show the icons here. Let me reload one last time.
Andrea, can you quickly show also did.dyn.org?
Sure.
Since you're already sharing the screen,
is anybody familiar with W3C DIDs?
With the W3C, probably the W3C Foundation in the US, standard organization, standard facilitator company.
So a W3C DID is an interoperable format for identifiers, which is basically used as a public infrastructure. We have our own W3C DID method, that's how it's called, which has been approved by the W3C Foundation. You can find the specifications here. I think it's dyn.org/W3CDID, if I'm not wrong.
Org.
All right, let's see, here we go. So those are the technical specifications. Here you find the source code. And here we actually have something funky to look at. Okay, that was the company. Since we worked a lot with blockchain, never with cryptocurrency, but with blockchain. We thought we would do an explorer for our DIDs. That's something to look at. So basically you click here and you can see a DID document that is owned by this DID.
We use the DID in production. It's probably the first completely production-ready open source implementation of a decentralized identifier out there. And this is completely implemented with Zencode.